Welcome back to the GMP and Quality Fundamentals series. This is video 12. If you've been following along from video 1, congratulations, you are almost at the end of level 1. And if this is your first time here, welcome. You can find the full series on this channel, starting from the basics. Today we're covering something that every single quality professional needs in their toolkit. Root cause analysis tools. Specifically, we are going to cover 3 tools. The 5 why method, the Fishbone Diagram, also called the Ishikawa diagram, and fault tree analysis. By the end of this video, you will know which tool to use, when to use it, and how to actually apply it in a real GMP situation. Let's get into it. Here is what we will cover today. Number 1, you will understand why root cause analysis even matters in a GMP environment. Because some people treat it like a paperwork exercise. It is not. Number 2, the 5 why method. This is the most commonly used RCA tool and the most misunderstood. We'll fix that today. Number 3, the Fishbone Diagram. This is a visual brainstorming tool that helps you see all possible causes at once. Number 4, fault tree analysis. This is the most advanced of the 3, and we'll walk through how it works. And number 5, we'll compare all 3 tools and give you a clear decision guide. Which one do you pick for which situation? Okay. Let's start with the most important question. Why does root cause analysis actually matter? Here is the problem. In quality, we deal with failures. A batch fails. A product tests OS. A deviation happens. And the natural human reaction is to fix the problem in front of us and move on. But here is the danger. If you only fix the symptom, the problem comes back. I want you to think about this analogy. Imagine a patient who gets a headache every Monday morning. They take a painkiller, the headache goes away, and they go back to work. Next Monday, headache again. Painkiller again. And this repeats for 6 months. A poor doctor just keeps prescribing the painkiller. A good doctor asks, why is this patient getting a headache every Monday morning? And they find out the patient is dehydrated every weekend. One conversation changes everything. Root cause analysis is the good doctor of quality. Now in GMP, this is not optional. FDA, EMA, and other regulatory authorities require documented root cause analysis in your deviation reports, your OS investigations, and your CAPA systems. We covered CAPA in video 7. If you haven't watched it yet, go back and do that. And from a business perspective, fixing a recurring failure once costs money. Fixing it 5 times costs 5 times more. Finding the root cause and actually solving it, that's where the real return on investment is in quality. Let's start with the simplest and most used tool. Tool number 1. The 5 why method. Simple. Fast. Surprisingly deep. The idea is exactly what the name says. You ask why 5 times. Each time, you dig 1 level deeper. Let's see it in action. Let's take a real scenario. Something you might see on a Monday morning in a pharmaceutical QC lab. The problem. An HPLC result for a product assay came back at 87%. The specification says it should be 98% or above. This is an out-of-specification result, an OS. Now, the wrong approach would be to say, the HPLC gave a bad result, retest the sample. But that's treating the symptom. The right approach is to ask why. Why number 1. Why did we get an OS result? Because the HPLC gave an unexpectedly low reading for the sample. Okay. We go deeper. Why number 2. Why did the HPLC give a low reading? Because the mobile phase concentration was incorrect. Interesting. Keep going. Why number 3. Why was the mobile phase incorrect? Because the analyst used water from the wrong bottle. They used reverse osmosis water instead of HPLC grade water. Now we're getting somewhere. Why number 4. Why did the analyst use the wrong water? Because the bottles were not labeled. The storage area labeling SOP was not being followed. Almost there. Why number 5. Why was the SOP not being followed? Because this analyst had not completed their training on that SOP. There was a gap in the training records. There is your root cause. Not the HPLC gave a bad result. Not human error. The root cause is a training record gap that allowed an unqualified analyst to perform a critical step. Now you can write a CAPA that actually means something. Update the training program. Add a verification check before analysts are allowed to prepare mobile phases. Problem solved, for real, not just for today. Before we move on, let me give you the most important rules for using the 5 why correctly, on the do side. First, focus on process failures, not people. The question is never who made the mistake. It is always why did the system allow the mistake to happen. Second, use evidence. Each answer should be supported by facts. Check records. Look at logs. Don't make assumptions. Third, it might only take 3 whys. You don't have to reach exactly 5. Stop when you get to the root. Sometimes that's 3 steps. Sometimes it needs 7. 5 is just a guideline to remind you to go deep enough. Fourth, involve the people who actually do the work. They know where the process breaks down. Sit with them. Now on the avoid side, and this one is critical, never accept human error as a root cause. It is always a symptom. Think about our example. Yes, the analysts used the wrong water, that's a human error. But why did they use the wrong water? Because they weren't trained. That's the root cause. Every time you write human error as a root cause, an inspector will push back. And rightly so, the golden rule. If you can ask why one more time and get a meaningful answer, you are not at the root cause yet. Now let's talk about tool number 2. The Fishbone Diagram. This is also called the Ishikawa diagram, after the Japanese quality engineer Kaoru Ishikawa who developed it in the 1960s. And sometimes it's called a cause and effect diagram, which is exactly what it does. The fishbone gives you something the 5 why does not. It lets you see all possible causes at once, organized by category. This is perfect for brainstorming sessions with your team. The most common structure for the fishbone in manufacturing and GMP environments is called the 6M framework. 6 categories of cause, all starting with M. Let me walk you through each one. M number 1, man or people. This covers training gaps, human behavior, fatigue, competency, supervision. Anything related to the people performing the task. M number 2, machine. This is your equipment. Calibration, maintenance, software versions, equipment failures. Did the machine perform correctly? M number 3, method. This is your procedures. Was the SOP correct? Was it followed? Were there unclear instructions? Was there no procedure at all? M number 4, material. Raw materials. Reagents, reference standards. Was the starting material within specification? Was the right reagent used? Was there contamination? M number 5, measurement. This category is about your testing itself. Was the measurement system calibrated? Was the sampling method correct? Could there be measurement bias? M number 6, Mother Nature or environment. Temperature, humidity, clean room conditions, cross-contamination from the environment. Especially important in microbiology and stability work. In GMP environments, I often see people use only 1 or 2 categories and ignore the rest. The power of the fishbone is that it forces you to consider all 6, even the ones you don't expect to be relevant. Some of the most surprising root causes come from unexpected categories. Here is what the fishbone diagram actually looks like visually. On the right, you have the fish head. That is your effect, the problem you are investigating. In this case, imagine it says product recall. From the left, there is a main horizontal line, the spine of the fish. Coming off the top of that spine, 3 diagonal bones going up. Each bone represents one category of cause. In our example, those are man, method, and measurement. Coming off the bottom of the spine, 3 bones going down. Machine, material, and environment. Each of those main bones has smaller subbranches coming off them. Those smaller branches are the specific possible causes within each category. For example, from the man bone, you might have subbranches like training not completed, SOP not signed off, or analyst distracted. This is what makes the fishbone so powerful in a team setting. You gather 5 or 6 people, draw this on a whiteboard, and everyone starts adding their ideas to each category. Within 30 minutes, you have a complete picture of every possible cause. Then you investigate which ones are actually supported by evidence. Now the most advanced of the three tools. Fault tree analysis, or FTA. While 5Y is linear, one cause leading to the next, and the fishbone is visual and categorical, the fault tree is logical. It maps every possible pathway that could lead to a failure, using Boolean logic. This tool is used for complex, high-risk situations. Think product recalls. Critical process deviations. Anything where you need to demonstrate to a regulator that you have considered every possible failure mode. Let me explain how FTA works. You start at the top, with the top event. That is the undesired outcome. For example, product recall. From there, you work backwards, top down. You ask, what are all the different ways this could have happened? You connect these causes using logic gates. There are two key ones. An OR gate means any one of the causes below is enough to trigger the event above. If any single one happens, the failure occurs. An AND gate means all of the causes below must happen together for the event above to be triggered. Both conditions must be present simultaneously. So in our example, we have the top event, product recall, at the top. Below it is an OR gate, connected to two intermediate events. A label error and a quality failure. Either one of those alone could cause a recall. Below the label error, we have an AND gate, meaning both a missing barcode and a verification failure would need to happen together to cause the label error. You keep building the tree downward until you reach the basic events, the fundamental root causes at the bottom of each branch. The FTA is especially valued in pharmaceutical and medical device industries where risk is highest. When an FDA inspector asks, "How did this happen and how are you sure it can happen again?" a well-built fault tree is your most powerful answer. So now you have all three tools. Let's compare them side by side so you know exactly which one to reach for. 5Y. Use this for simple, linear problems. Low complexity. You can run it with just 1 to 3 people. Classic GMP use cases: an OS result, a daily nonconformance, a documentation deviation, fishbone. Use this when the problem is more complex and could have causes in multiple categories. Medium complexity. Best done with a team of 4 to 8 people. Great for recurring failures or batch release issues where you're not sure where the cause is hiding. FTA. This is for your most serious events. High complexity. Requires a larger team and proper facilitation. Use it for product recalls. Critical deviations, or any event that requires a comprehensive safety risk assessment. And here is a powerful combination strategy. Start with the fishbone to identify all possible cause categories, then apply 5Y within each relevant branch. You get the broad view of the fishbone and the depth of the 5Y together. This approach is particularly effective for CAPA investigations that need to stand up to a regulatory inspection. Let's bring it all together. 5 things to remember from this video. Number 1. Root cause is not the immediate cause. Don't stop at the first answer. Dig deeper until you find the origin of the failure. Number 2. The 5Y is your everyday tool. Fast, simple, and sufficient for most deviations and OS investigations. Number 3. The fishbone gives you the full picture. When you don't know where the cause is hiding, map all 6 categories with your team. Number 4. Fault tree analysis is for complex, high-risk failures. Use Boolean logic to map all pathways. This is what serious investigators use. And number 5, this one is the most important. Human error is never a root cause. It is always a symptom. Every time you are tempted to write human error, ask yourself one more why. Why did the human make that error? That answer, that is your root cause. That's video 12 done, and congratulations, you have now completed level 1 of this series. We've covered GMP basics, laboratory testing, risk management, deviations, CAPA, change control, data integrity, audits, batch records, and now root cause analysis. That is a serious foundation. Coming up next in video 13, we move into level 2 with one of the most important regulatory frameworks in all of GMP. ICHQ9 and risk-based thinking. You'll learn how regulators and quality professionals evaluate risk scientifically, and how to use risk to make smarter quality decisions. That video is going to connect a lot of dots from what we've already covered. If this video was useful to you, please give it a like. It genuinely helps this channel reach more quality professionals. Subscribe if you haven't already. We upload new GMP content every week, and drop your questions in the comments below. I read every single comment and I will reply. I'll see you in video 13. Stay curious. Keep asking why.